Good morning, everyone. Welcome to Considering God's Works. This is a class where we explore the interface between theology and science. Today we're going to be talking about what I call foundational faith assumptions of science. And sometimes I might use the phrase metaphysical presuppositions or philosophical presuppositions. But what I'm really talking about here is assumptions of faith that guide the way that we see. So we'll be talking about foundational faith assumptions of science, but also the role of science in faith. And we'll be thinking about that throughout this class. And in particular, we'll be looking at a few case studies in the history of science where faith assumptions have played a pivotal role in the development of individual scientific theories. And I always find these case studies interesting because the other week, I think it was Matt Terry was sort of asking about, well, are there any examples of the role of faith in science? And so today we'll be talking about some examples. A few weeks ago, we spoke of the basic components of science, and we said that science consists of data, which are collections of information about physical processes that are gained through observations of the natural world, and sometimes experiments too, but not always, because in the historical sciences, we can't do experiments in the same way we can in things like quantum physics. So observations is the more general term of how we get data. Theories are how we put this data together. They are empirical generalizations of data and conceptual constructions that help us explain why the data exist, why the data look like they look. And then there's this thing called shaping principles. And when we think about science, most of us really don't think about shaping principles too much, but these are non-empirical factors and assumptions that go into science. These are both current and historical, and these form the basis of science and go into how do we select a good theory, whether that's because of the mathematical beauty of a theory or because it has certain value to us in other ways. These are shaping principles. Things that go into shaping our motivations, our inspirations, but also sometimes selecting a good theory. So today we're going to talk about general presuppositions in science, or what I call faith assumptions in science. And again, these are key shaping principles in science. And these, says physicist and philosopher of science, Mariano Artigas, he says these types of things, these shaping principles or faith assumptions, continue to be present not as a kind of philosophical ornament, but as a real part of science itself. When we study the presuppositions of science, we are studying science itself in a strict sense. So again, just to stress that idea that shaping principles are a key part of science itself, not just some sort of additional or bonus part that comes out of science. A few weeks ago, we saw this guy here, physicist Paul Davies, and he told us that science began as an outgrowth of theology, and all scientists, whether atheist or theist, accept an essentially theological worldview. And we spoke about why that was so. Another physicist by the name of Peter Hodgson, who's at Oxford University, actually he's the late Peter Hodgson now, but he was an Oxford physicist. He says theological beliefs can have both internal and external influences on the development of science. Indeed, for science to develop, these beliefs must be held, at least implicitly, by society as a whole and by scientists themselves. And so we spoke about a few foundational faith assumptions of the natural sciences. And we said that these came from a theological framework and a philosophical framework that stem from early Jewish and early Christian understandings of Scripture and the natural world. And this had to do with how these early Christians and Jews read the Bible and understood what they called the works of God in creation as they were revealed in the world of nature. We spoke about 4 of these. We could probably have a list of maybe conservatively speaking 15. If you want to see my extra slides at the end, we can talk about more of these, but I thought we won't get confused if we talk about these 4. We spoke about these a few weeks ago, so I'm just going to do a quick review. The first was the de-divinization of the world, the relative autonomy of nature, the comprehensibility or intelligibility of the world, and the unity of heaven and earth. Again, what is the de-divinization of the world? Well, this was the idea from early Christians and Jews before them that the cosmos is not divine. There is an absolute distinction between the creator and the creation. That's why we should not worship the creation. The sun, moon, and stars, for example, and the earth, they're not gods. They're God's handiwork. They are not rival gods. And this was a very controversial idea in the ancient world that Jews and Christians held, in opposition even to philosophers like Aristotle. Number two, the relative autonomy of nature. This is an idea that nature is governed by its own laws of operation, that nature operates in accordance with principles that make it regular and predictable. And this eventually led to what we call today is methodological naturalism, the idea that when you look at nature and science, you methodologically speaking, you take a naturalistic view that God is not going to be involved when I put this ball on an inclined plane and it rolls down and I study it. We're assuming that God isn't going to intervene in that process. And so, but not that God isn't active in nature, but there's this idea of relative autonomy of nature. And we'll talk about that a bit more when we get into the issue of miracles and how God acts in nature in a future class. The third view we talked about was this idea of the unity of heaven and earth. And this means that there's no essential difference, physically speaking, or any sort of duality between the earth and the physical heavens, the place where the sun, moon, and the stars are. In other words, there is a single physics, and this is what Basil Caesarea told us, that there's a single physics for the heavens, the realm of space, and earth. That the stars and the sun were not made of a completely different element, but they were made of a sort of fire that's similar to the fire that we find here on earth. And so this is the argument you find in the early church. This understanding led to another presupposition, which we call the uniformity of the laws of nature, or cosmic uniformity. The idea that if we measure the speed of light here at Lawrence Berkeley Labs on the hill, and we go down to the coast, that the speed of light will be the same, though we actually haven't physically measured it there. We assume that there's this uniformity to the laws of nature, that the speed of light on the hill will be the same on the coast, but it will also be the same on the moon and on the other side of the cosmos. So there's this assumption that the laws of nature apply even where we haven't been, and that comes from this idea of the unity of heaven and earth. Then the fourth one we talked about was the comprehensibility of the world. We said there were three components to this idea, and this was basically the belief that the physical world is open to human inquiry and comprehension. And the three components were, one, that there's a lawfulness, a wisdom or logic to the natural world. And so you find the early church talking about God's laws of nature. Today we take out the God part of that and we say laws of nature. But originally it was God's laws for nature, or God's laws of nature. The second part was that the human mind is capable of discerning the logic of the natural world, even in its more complex and remote aspects. And this was something that was in principle held in faith, the idea that even if we don't have the right instruments today to understand this, that in principle the universe is comprehensible. The third part of this was that both the logic of nature and the creative reasonings of humans are both rooted in this transcendent order, which was spoken of as a divine logos, and that's the Greek word for word. Jesus is said to be the logos. In the beginning was the logos, and the logos was with God, and the logos was God. Or sometimes the Jews spoke about a wisdom, and Christians did too. This wisdom or logos, this logic that creates and upholds all things. And so the idea that this divine wisdom or logic is throughout the whole creation. So those were the four faith assumptions or general presuppositions which they worked their way into early modern science, and they even today continue throughout. We'll talk about that in a bit more. But again, these are faith-based or metaphysical, which is a philosophical word for that, in that they are beyond the scope of the experimental sciences themselves to establish or evaluate. These presuppositions cannot be proven within science itself. Yet, the entire scientific enterprise would be impossible without these presuppositions and other presuppositions that are similar. However, such presuppositions involve faith, but it is not necessarily a blind faith. The progress of science enables a kind of feedback on these very presuppositions. For example, we may begin our scientific enterprise by assuming the uniformity of nature, the intelligibility of nature, the relative autonomy of nature, and the rational order of nature. And then we look for these things in the natural world, and when we find these, our success prompts us to search for new and unexpected forms of uniformity, rational order, and autonomy in nature. So we measure the speed of light in Berkeley, we measure it in Geneva, we measure it wherever we have a lab that can measure it, and then we say, boy, it seems to be the same everywhere. And so there is this progress in science that justifies our presuppositions. We still haven't measured it on the other side of the cosmos, but we have this feeling that we're getting closer to truth. The success of science then retro-justifies, and this is a term by a philosopher of science named Nicholas Rescher, and this means to justify after the fact of its discovery, you could say, or the fact that you do find these things in nature. And these presuppositions are then refined, and then we still have general presuppositions, but they become stronger the more that we find, is the basic idea of that. So the more science progresses, the more we can be sure that we are grasping in some way a natural order which is independent of us. That there's something, all this stuff is not just in our heads, there's something out there. Because the success of science is seen as a justification for these presuppositions, many scientists might not even acknowledge these as presuppositions, but rather they might see them as givens or no-brainers. So if you talk to your average practicing scientist, my guess would be that they've actually never really thought about these things. Like I had I'm trying to think if she was a chemist or a physicist, come up to me recently at a conference, and she said, someone here told me that you study the philosophy of science, and I was wondering, as a physicist, would I just know that? Would I just understand that just by studying science? Sort of that you would just get that intuitively by studying science, you'd understand the philosophy of science. And I said, well, what is your idea of presuppositions in your work? And she said, what? What are you talking about? And so we went through a few of these, and talking about these, she saw the role of them, but she had never thought about them before. And so that's been my experience with most scientists I've spoken to about presuppositions, is you never really think about these things. They're givens, but they're always there. However, these assumptions are not givens, or at least not in all cultures. Almost every one of these faith assumptions has been challenged or questioned at some level by professional philosophers of science. And a lot of these are philosophers from non-Western cultures. So this has been particularly the case with philosophers outside of Western and Eastern Christian cultural context, who have questioned the metaphysical beliefs in, for example, the uniformity and comprehensibility of nature, causality, realism, and even the de-divinization of nature, this idea that nature shouldn't have the divine. You have a resurgence of pantheistic views on the horizon that are really taking some, they're getting philosophical force. And so you have philosophers of science from these traditions and also from Hindu traditions and Buddhist traditions saying, well, should we really assume linear causality? Why not reverse causality? And so you have these sort of questions, a lot of them in quantum physics, but in other places as well. So we can't just accept these as givens. We need to own up to these from our cultural and our theological context. But some early Christian convictions about the natural world are not among these general presuppositions of science, the ones we spoke about and other general presuppositions that we could speak about. These include beliefs such as that the cosmos had a beginning. This is not a belief that is absolutely foundational to doing science. This is something that all Christians believed. That the cosmos and physical reality are historical and linear, and that kind of goes with the idea that the cosmos had a beginning. The idea that there is such a thing as time, and time is going somewhere in a sort of line. God created the world, We live in the world, things are happening, God's working in the world, and there will be an end to the world. And so you have a very specific timeline that is essential to this Jewish and Christian concept of reality. But you can do science without this timeline. You don't need this time. You could believe in a cyclical universe and still do science. It's not a general presupposition that the planet Earth had a history. So there's this idea, we find it in Genesis and other places, that God created the earth, right? That the earth is not eternal. But again, this was a belief that Christians had that others like Aristotle did not have, but they could still be very scientific. Christians had this belief that creation is creative. God said to the animals, be fruitful and multiply. Basil of Caesarea even read Genesis when God said, let the earth bring forth. God said, God even made the very earth creative so that the earth could even create. And so this idea that creation's creative was believed by many Christians, but not a general presupposition of science. And the last one as an example, and there's many of these, was that the human race is united through a common ancestor, or through common ancestors, which Christians called Adam and Eve. And Paul talks about through one man came all men. This idea, in his sermon in Athens, this idea that we're all united in this brotherhood. Despite our racial characteristics being different, we're all united in this single brotherhood that goes back to Adam and Eve. We're all one family. And this was a assumption of Christians. Again, you can do science without this. But such faith commitments have served as particular presuppositions for specific scientific theories throughout the history of science. So these aren't unimportant. Though you can do science without these have played a role in science. Particular faith commitments or assumptions actually have played an extremely important role within specific historical contexts of certain scientific theories. And they have acted as key factors or shaping principles as these theories were developed. 3 specific areas where specifically Christian faith assumptions or presuppositions have driven the inspiration, research, and continued development of particular scientific theories are geology in the 18th century, evolutionary biology in the 19th century, and cosmology in the 20th century. These are only 3 small areas of science where specifically Christian presuppositions that were particular to Christianity and Judaism and not shared by other faiths. Some of them may have, some of them might not have, but these were Christians that were doing this science and choosing these presuppositions. So these are 3 areas. I've chosen these 3, though there are other areas we could talk about. I have chosen these 3 because ironically, these are the 3 areas that young earth creationists deny the current consensus of science. So this is these are areas of controversy within the Christian church today. That's why I've chosen these 3 areas, specifically because they're controversial areas. So I thought we'd find it interesting to see what was going on as these sciences were developing. So what was going on in 18th century geology? Well, there were 2 competing scientific frameworks when the geological sciences were first developing in 18th century Europe. And these were 2 competing metaphysical frameworks, or we'd call them research paradigms if we were to use contemporary language of philosophy of science. And there were 2 early geological theories, right? So these are theories about what is Earth like? What's the nature of Earth scientifically? The first was geologic eternalism. And we'll talk about that a bit more in a second. And the second was historical geology. These 2 frameworks had distinct faith assumptions, distinct philosophical presuppositions, or particular presuppositions about the nature of the earth that informed their research and their overarching scientific theories. So the question between 1700 and the 1850s, actually really from the late 1600s through the 1850s, was, does Earth have a true history? And true history in the sense that there's actually something going on in a linear, progressive, in a certain way that where things are not repeated. The one view, which was geologic eternalism, said no. And they preferred the theory of what they called the eternal present. This means that the planet Earth is eternal, and its processes and basic features have essentially been the same forever. And the inspiration here was Aristotle, but also others. We find this in the work of geologist James Hutton. Hutton says we find no vestige of a beginning and no prospect of an end when we look at the data from the Earth, from the strata, from the layers of soil. When we do geology, there's no sense that there was any beginning to the planet ever, and there's no sense that it will ever end. And he made his point very clearly in his very well-read work that the terrestrial system was in fact eternal, even though it was beyond human capacities to ever demonstrate this conclusively. He believed that we could never demonstrate it, but he argued that that makes the most sense according to the empirical data. So geologic eternalism assumed that there had never been a time when the world was without human, or at least rational life. It allowed for no conception of a pre-human and therefore a radically non-human world. So humans have pretty much always been here, or some sort of rational life has always been here. And this was held by Enlightenment scientists who were mainly of atheistic and deistic opinions. The other view is what we would call historical geology, or what's called historical geology. This was opposed to geologic eternalism. This view said that the planet Earth is not eternal, that Earth had a beginning. Earth's processes are not cyclical, but linear. And Earth has gone through various geological ages over time. Each of these ages, in fact, was quite distinct in its geological characteristics. And the distinct historical epochs are represented in the sedimentary layers. So while the processes of Earth are regular, these processes themselves also have a history. So this was the view of the historical geologists. And while the geologic eternalists were primarily atheists and deists, the historical geologists were predominantly devout Christians whose belief in a finite historical Earth allowed them the intellectual space, or the intellectual freedom to work out the actual history of the Earth. And one key person here who's in this slide is Nicholas Steno. He was actually Danish. That's a Latinized version of his name. I think it was Niels Stensen was his actual name. But he is called the father of stratigraphy, and we'll talk about stratigraphy in a bit and what that actually is. But he was also a Roman Catholic bishop and a Roman Catholic saint not long after his death. He was born a Lutheran and raised a Lutheran, but he decided that Catholicism provided more sustenance for his scientific inquisitiveness than Lutheranism, so he converted as an adult to Catholicism. So Steno discovered three of the defining principles of the science of stratigraphy. The first is the law of superposition, and we see this here, and this says that rock layers are essentially deposited from the bottom up. And so if you think of, you have this here, this layer of sediment forms, and then this one forms on top of it, and that this one forms on top of that. And that there's a chronology to this, that the oldest layers form first, and they're at the bottom, and the younger layers are towards the top. And if you think about this, it makes a lot of logical sense. But when put together, you find very interesting things happening. The second was the principle of original horizontality. Again, this says that when these layers formed, they were originally horizontal. Makes a lot of sense when we look at how soil layers form. But again, when you put these things together, you find very interesting things happening. The third was the principle of lateral continuity. This is the idea that when original layers of sediment form, they're continuous laterally or horizontally. And so if you find yourself walking in a valley, like in this image here, and you see these three rock layers here, and you see an opposing cliff bed with three similar rock layers, you say, well, boy, there must have been some erosion. Maybe the stream in this valley cut through this mountainside or cut through the sediment. And this idea that these layers were originally continuous across the valley, since they look so similar. So these were three basic principles of geology. And these principles actually provided the basis for the development of the geologic timescale, which was worked out over a couple hundred years. And here I find this a very helpful image of the geologic timescale because it's readable and it's sort of fun. But what Steno also did was he made an argument. He understood that fossils that we'd find in layers were actually organic, that these belonged to creatures that are now dead or even extinct, and that there were connections between fossil layers and different types of rocks. And so this idea that different layers of sediment had particular fossils was something that was discovered by Steno. We also have people like William Strata Smith, and he was the one who did this map here of England. He's called the father of English geology. He was also a devout Christian. He created the first nationwide geological map, which you see here in this slide. And this map was issued by the Society for the Promotion of Christian Knowledge. Adam Sedgwick was another early geologist. He was an evangelical Christian, and he also was a geologist who was the key person in defining what's called the Devonian and Cambrian periods. William Buckland was another well-known geologist and paleontologist. He wrote the first full count of a fossil dinosaur. In this image, you see his drawing of the jaw of Megalosaurus, as he called it, which was our first description of a dinosaur. He argued that the Earth is millions and millions of years old, and he was also a very devout Christian as well. Daniel Conybeare was a geologist, paleontologist, and a Christian clergyman. James Dwight Dana was also an evangelical Christian, but he did key work in mountain building, volcanic activity, and the origin and structure of continents and oceans around the world. And so this is just a small example of some of the geologists who were all devout Christians who were developing this early idea of historical geology. But what's important here is that they were assuming that Earth had a history and that Earth had a beginning, and that there was a potential for a pre-human or a non-human world before humans ever arrived. And if you read your Bible, you see that. All these people were also what we'd call day-age theorists, that they read the early church fathers who said, well, these are not literal 6 24-hour days, and so they were not at all constrained by what we would call today as young earth creationism. So none of them were at all constrained by this view in their work. This was a view that had, it really didn't have a lot of cultural influence at the time in the way that it does now. So eternalist geology dismissed the notion from historical geology that the Earth had a beginning. They saw this idea as mere metaphysical speculation into the realm of that which cannot be immediately observed. So historical geologists said, you can't tell Earth had a beginning or a real history, so you're just metaphysically speculating. The idea of a geologic beginning and a geologically progressive time contradicted what they saw as the clearly observable cyclical processes of Earth. In other words, the eternal present, which the geologic eternalists held as empirically certain. The linear model of Earth history, which was seen by them as influenced by Christianity, was held by eternalists as mistaken because it undercut the observable, uniformitarian, steady-state model of Earth history. Initially, the data from the stratigraphic record could be interpreted in light of either paradigm and could be seen to support both of these equally. And that's very important to keep in mind. It was only later, as sufficient empirical evidence from the geologic record accumulated, that one could eventually decide definitively between these two competing scientific or metaphysical frameworks, between Enlightenment eternalism and the temporally changing historical Earth of Christian metaphysics. We now take it for granted that Earth has a history and a distinct beginning in time. We talk about Earth as being 4.6 billion years old. Before that, Earth did not exist. We take that for granted now. But at one point in the history of science, this was purely a metaphysical assumption which served to guide the direction of a specific scientific research paradigm of the time. So this idea that Earth has a history actually created this intellectual space or freedom for these early scientists to work out the geologic record. And this idea, of course, as you know, came straight from Christian metaphysics. The second area we're going to talk about is evolutionary biology in the 19th century. So we might ask, who was Charles Darwin? Well, many people think of Darwin in terms of what is actually a myth. People think Darwin changed the world because he was a tough-minded scientist doing good empirical science without any philosophical or religious trappings to cloud his objectivity. Some might say that Darwin's single-minded pursuit of science and unhindered objective zeal for scientific knowledge kept him on target to overthrow God and bestialize humanity. Others might even say that Darwin was hell-bent on annihilating the Christian concept of Adam. The truth, however, is quite different. According to two historians of science and authorities on Darwin, academic authorities who've wrote biographies and pretty much a ton of stuff. If you're going to read anything academic on Darwin, it will have been written by one of these two people. Their names are Adrian Desmond and James Moore. They say that this idea of Darwin isn't just simplistic, it's plain wrong. They say that human evolution wasn't Darwin's last piece in the evolution jigsaw, it was the first. From the very outset, say Desmond and Moore, Darwin concerned himself with the unity of humankind. This notion of brotherhood grounded his evolutionary enterprise. The unity of humankind, which is often referred to as monogenism, which means from one birth, was in fact a key faith assumption and a metaphysical motivation which drove Darwin's scientific work. And I want that to sink in, that this idea of the unity of humankind was a key faith assumption of Darwin that drove his work in evolution. Again, Desmond and Moore write, a moral passion firing his evolutionary work. This idea of the unity of humankind was a moral passion firing his evolutionary work, guiding both his understanding of human descent and his adamant antagonism to polygenism. And that's this idea that the different human races come from different origins, this idea of polygenism. So where did this moral passion or faith assumption come from in Darwin's mind? Where did Darwin get this? Well, Darwin's family, when Darwin was growing up, his family on both sides, on his maternal and paternal side, were deeply involved in the abolitionist movement that was led by evangelical Christians such as William Wilberforce and Thomas Clarkson. Now, what I mean by abolitionism is the movement to eradicate slavery, to get rid of the slave trade, to get rid of the institution of slavery. Now, Darwin's family was very much involved in this movement. If you haven't seen the movie Amazing Grace, which tells you the life, sort of the journey of William Wilberforce in this, William Wilberforce was an amazing evangelical Christian who was a member of Parliament that was fighting against the slave trade and against the institution of slavery, and so was Thomas Clarkson. And so I would recommend Amazing Grace if you want some details of this. Josiah Wedgwood, which was Darwin's grandfather, actually financed this guy, Thomas Clarkson, who's in the movie Amazing Grace. And in fact, Wedgwood, if you know Wedgwood pottery, that's from this same Wedgwood here. Josiah Wedgwood, who was Darwin's grandfather, actually designed the official seal for the anti-slavery movement. And so here we see this seal here that has a slave in chains, and it says, "Am I not a man and a brother?" And so he'd put this on pottery, which they'd distribute. He distributed at his own expense to lots of people, sort of trying to make the movement very fashionable. And they would have sugar boycotts because the sugar was based on the slave trade. And so here you see a Wedgwood sugar bowl, which everyone who was part of this boycott would get a Wedgwood sugar bowl. And so it was sort of this. The idea was that the Darwin family was central to this abolitionist movement in Victorian England, or I guess this wasn't quite Victorian England yet, but in pre-Victorian England. So Darwin's starting point from his childhood was this abolitionist belief in what they call blood kinship, or common descent. And this was an understanding they got straight from Christianity, because all these people are evangelical Christians that we're talking about here. And so, again, Desmond and Moore say Adamic unity in Adam and the brotherhood of man were axiomatic in the anti-slavery tracts that Darwin and his family devoured and distributed. It implied a single origin for black and white, a shared ancestry. And this idea of a common ancestry was the unique feature of Darwin's peculiar brand of evolution. Darwin was in fact driven into his scientific research by his conviction, his faith conviction, that all humans were united through their common ancestry, this idea of the unity of humanity. This led both to his hatred of racism and his opposition to the slave trade. These factors shaped Darwin's thinking and resulted in his single-minded effort to develop a picture of the natural world that could counter the prevailing belief in his time in the immutability of species and in the superiority of the white race. This idea that all these races had distinct origins and all these animals had distinct origins was what Darwin was fighting against to prove this idea of the unity of humanity. Rather than seeing the facts force evolution on Darwin, we find a moral or a metaphysical passion firing his evolutionary work. Darwin enlisted his scientific mind to the aid of the monogenist and abolitionist cause. Wading increasingly against the tide of the new scientific thought, he offered evolution through natural selection as an empirical foundation to the unity of race thesis. And now, what's interesting is we lose the context of where Darwin was doing his work and when Darwin was doing his work. He was actually going against the grain, arguing for this unity of humanity idea, right? And so it's important to realize that Darwin here is driven by this faith assumption that comes from his very early days. His very early days influenced his mind in this. But this is what he was trying to prove in his work in evolution. Another historian of science, Joel Schwartz, says, Darwin wanted to provide a strong foundation for his ideas about the mutability of species and the unity of life and humankind because he was aware in the mid-19th century that, and this is a quote from Darwin, the cutting edge of science was becoming less and less hospitable to Darwin's idea of descent from a single stock. So this idea of common ancestry that comes from Christianity was not popular in Darwin's day. What's interesting is Darwin was the one who gave this scientific footing. And this was driven by a metaphysical foundation which was at the very beginning of his science. The third area that we're going to talk about today is 20th century cosmology. You all probably recognize Albert Einstein there. In 1916, he published a paper which described his theory of general relativity. What this did was provided a unified description of gravity as a geometric property of space and time. And we kind of see a little bit of that in this image here. We're going to talk about relativity in its details in a future class, so I'm not going to go into it now, just to mention it. But what was interesting from the presupposition side of things is that Albert Einstein believed, with most physicists since Newton, that the universe is static, eternal, and infinite. That's when he developed his theory of general relativity. That is what Einstein believed. These particular faith assumptions regarding the nature of the universe blinded Einstein from deriving the correct physical interpretation of his own equations of general relativity. So Einstein developed this theory of general relativity, but he developed it and he actually added some constants to continue to see the universe as static and eternal. Einstein's received cultural belief about the nature of the universe did not allow for him to see an expanding universe with a beginning. And so he actually fudged with his mathematics a little bit to make sure that there wasn't a beginning to this. And that's saying it very crudely, but we'll talk about the details later. With this metaphysical framework in mind, Einstein rejected solutions to his own equations that implied an expanding universe. As a result, Einstein, and this is in hindsight, he lost the opportunity to receive an additional Nobel Prize. And later in his life, he referred to this inability to see beyond the received understanding of the universe as one of the biggest regrets of his life. And so here we have Einstein's metaphysical presuppositions, which were shared by many physicists at the time. However, Alexander Friedman did not share Einstein's presuppositions about the universe. And in 1922, he presented a solution to Einstein's equations which indicated the expansion of the universe. So what made Friedman different? Well, Friedman was a devout Eastern Orthodox Christian who, against the prevailing view of the times, was willing to assume an expanding of space and time, and thus a beginning in his working out of Einstein's equations. Well, why was Friedman willing to assume this? Well, we read from historian of science, Jean-Pierre Luminet, that for him, general relativity suggested the creation of the world by God. In fact, Friedman's Christian faith favorably disposed him towards a scientific interpretation which Einstein would not, and some would say could not, consider. It was outside the range of his comprehension because of his presuppositions. Friedman thought the Christian assumption about the nature of the cosmos as one which had a beginning was both theologically more sound and mathematically more consistent than Einstein's own understanding of his own equations. Another person who studied Einstein's general relativity was this man here, Lemaitre, who was a Cambridge astrophysicist and a Belgian Roman Catholic priest. And he was likewise open to this idea of the expanding universe, and that's how he interpreted Einstein's equations. Thus, in the 1927 paper, Lemaitre proposed that the universe was expanding. He welcomed the idea of a cosmic beginning, rather than finding it as physically abhorrent as many other physicists at the time did. Lemaitre projected back the expansion of the cosmos, and he further concluded that an initial creation-like event must have occurred. And he called this theory the theory of the primeval atom. Lemaitre's paper in Nature originally even had references to God in this creation event. But he removed them. He removed all of his theological references, and we have the original typed paper, so we see that he did this, fearing that it would bias other physicists against his interpretation. That if you made any reference to creation or God, people wouldn't buy it. And he did this with good reason. For instance, at a conference near Brussels, shortly after he published his paper, Lemaitre grabbed Einstein from a crowd of people, drew his attention to his own results, and asked him what he thought. Einstein's response was, "Your calculations are correct, but your physical insight is abominable." So this idea that his understanding of the physical universe was just crazy, that this idea that the universe was physically expanding was, in Einstein's own words, abominable. Another historian of science, Helga Krok, says, "It is most remarkable that neither Friedman's nor Lemaitre's works made any impact at all. They were published in all the right journals at the right time with the right questions, but they made no impact." He says, "The reasons for the neglect are not entirely clear, but ingrained belief in the static nature of the universe was undoubtedly an important socio-psychological factor." Right? And that's saying it mildly. Krok is he's a very cautious historian of science, which makes him a good resource. But there's certainly something at work here. Others would go beyond that. And we know that, in fact, Friedman and Lemaitre's interpretations of Einstein's equations were actively opposed by fellow cosmologists on explicitly theological or metaphysical grounds. The greatest opponent to Lemaitre's Big Bang theory, who in fact gave it its name as a way to poke fun of it, right? And so that the Big Bang wasn't Lemaitre's own name for his theory. He liked to call it the primeval atom theory. But this guy here, Fred Hoyle, who was actually a colleague of Lemaitre's at Cambridge, he coined the term Big Bang, and he opposed this idea on specifically theological grounds. He was annoyed by the theistic implications of Lemaitre's theory, and thus Hoyle developed a rival theory, which he called the steady state theory, and even popularized this theory in a series on BBC Radio. Now, Hoyle was a great promoter, and so he really gave Lemaitre a tough time with this idea of the Big Bang. And the fact that we're all calling it the Big Bang shows you how successful Hoyle was. But Hoyle's atheism was a key motivator in the development of his alternatives theory, as it was in his lifelong refusal to accept the Big Bang theory. So even after all the experimental evidence came in, Hoyle would never accept the Big Bang theory because it looked too much like a creation event. It looked too much like something's going on here that is blatantly theistic. Historian of science Edward Davis says precisely because he did not believe in God and because he did not like the implications of Lemaitre's theory, Hoyle ridiculed it and proposed the steady state theory to provide an alternative explanation without the implication that the universe had a beginning. So here again we find faith assumptions, metaphysical presuppositions in action. So what are some conclusions to take home from today's class? Well, the primary one is that particular faith assumptions from theology and from atheology, meaning atheism, it's not just a one-way street here. Your geological eternalists were atheists who chose that view in a large way because they did not like the Christian implications of a beginning to the earth. And that's the same with Fred Hoyle. So both atheism and theism have played a key role in the actual course of scientific theorizing. Faith assumptions have played key roles at the levels of inspiration, motivation, research, and the development of particular scientific theories throughout the history of science. We first talked about 18th century geology, and here the key faith assumption for the historical geologists was that planet Earth had a true, a linear, and not cyclical history, and that planet Earth is not eternal, but had a beginning. That was a key faith assumption that was in fact substantiated by the empirical evidence in time. In 19th century evolutionary biology, the key faith assumption of Darwin was the unity of humanity, this idea that all races share a single Adamic history. And so this was, again, the view that was supported by the empirical evidence. This idea of Darwin's that he got from his childhood and the being involved with all the evangelicals in the abolitionist movement. The last faith assumption we talked about was that by Friedman and Lemaitre, that the universe had a physical beginning, and that allowed them to see beyond Einstein's own understanding of his own equations and arrive at the correct, at least as far as we know in the history of science today, the correct physical interpretation of the universe. And that's a universe with, as far as we can tell, something very much like a beginning. So the question I leave you with today then is, considering the role that these faith assumptions have played within these particular sciences, what should be the role of the same scientific theories in our faith today? So the fact that these theories were front-loaded with faith, and now we have these theories that we think about and we talk about in church, many of them very controversial. What role should these very theories play in our faith today? And that's something we'll pick up in the next few classes. We're going to talk a little bit more about history, and then we're going to go straight into the science. But I want you to keep this question in the back of your minds as we talk about these sciences, and think about where these sciences came from, the metaphysics that drove these sciences, or the faith assumptions that drove these sciences. If you want to learn more about today's class, there's 3 books. The first one's readable. This is Darwin's Sacred Cause by Adrian Desmond and James Moore. I had a lot of quotes from them from that book. Very readable. This book might be 1,000 pages long. It's about this thick, hardcover. But if you really want to get into the question of the history of geology and this question of eternalism versus historical geology, Martin Rudwick, who's a Christian, he's an evangelical Christian. I think he's evangelical, but I know he's a serious Christian if he's not an evangelical, which I think allows him to write more freely on the role of faith in science. He's also, I'd say, the top historian on the history of geology. So those two things can coincide. But I would recommend his book if you want to go into details. Helge Krok, I do not know what his faith is, but he's written a lot of good history in the area of cosmology, and so I'd recommend this book if you want to go into the question of contemporary cosmology and what was going on with that discussion in the 20th century.